Hello and welcome to the course of HDL Digital Circuit Design. Today's topic is Verilog code for 4:1 MUX in behavioral modeling style. Myself Shilpa Kedarudrawar, Assistant Professor, School of ENTC Engineering, MIT Academy of Engineering, Anandi, Pune. So moving ahead with the today's topic, that is Verilog code for behavioral modeling style. Now what is modeling style that I have already covered in the previous video. The link of that I'll be putting in the description box. So kindly go through it. Along with that, I have created a video for 4:1 MUX Verilog code in Dataflow modeling style using ternary or conditional operator. That link also I'll be putting in the description box. So kindly go through that. So you can write Verilog code in different modeling style, that too using different operators and different styles. So it is not that in one modeling style you'll be writing the code in that way only. So ternary operator, you can write a code in Dataflow using and or gates also by having the equation also you can write a Verilog code in Dataflow modeling style. Same way, whenever you are going ahead with the behavioral modeling style, you can use case statement or you can use if-else statement or you can use loop for statement. So there is no only one method to write a code. So moving ahead with the different modeling style, which I have covered earlier also. So whenever the digital circuits come in your mind, so it is combinational and sequential, and you will be thinking that it is in the circuit form, or it might be in the form of expression, or it might be in the form of truth table. So from that you can imagine or consider the sequential and combinational circuit. Now in the same way you can model the circuit in Verilog, or you can model the Verilog code in three modeling style, that is structural or gate level, data flow and behavioral. Data flow we have already covered, that is 4:1 MUX using data flow modeling style. Now we'll be going ahead with the behavioral modeling style, and in this tutorial we'll be seeing how to write 4:1 Verilog code in behavioral modeling style using case statement as well as for if-else statement. So moving ahead with the code. Uh, Before that, what is behavioral modeling style? So in that behavioral modeling style, you should know the truth table or behavior of the circuit. There is no requirement of understanding the component level representation. So that is not required. In data flow modeling style, you need to understand the components. You need to understand the equation A and B. So AND gate is there. That way here it is not mandatory. You should be knowing truth table or behavior. So this is recommended for FPGA prototyping and reconfigurable devices. So this is the highest level of abstraction out of uh, this data flow and structural. This is the highest level of abstraction. Now, what is MUX? Already I have covered. Still, I'll be briefing in short. That is, MUX is the data selector. That here you are able to see the MUX diagram where you are having A, B, C, D, that are the four inputs, and two select line. Depending upon select line, whether it is 0, 0, 0, 1, 1, 0, and 1, 1, A, B, C, D respectively, one by one, it will be switching to the Y. Meaning of that, if select line is 0, 0, A will be connected to Y. That is output you will be getting whatever present at A. If A is 0, you'll be getting 0. If A is 1, you'll be getting 1. So whatever data present over here will be connected to Y. Same way 0, 1, you'll be getting B. Whatever there is the data on B, you'll be getting at the output. Likewise, you'll be going ahead with the C and D. Now the truth table is also shown. Select line 0, 0, 0, 1, 1, 0, 1, 1, and you'll be getting that way respective output at the output side. Now here purposefully I have written a code which is having this numbering so that no line will be missing. Now how to write a code? So structure of Verilog code, how to write. Again related to that also video is created. I'll be putting that link in the description box. So if you required to understand the basics over there, you can go ahead with that video. That is a short video of 10 minutes only. So whenever you are writing a Verilog code, you need to start with the module and you need to end with end module. Now you need to give the name to the module. That's why it is given as a mux underscore 4 underscore 1. You can give any name. Don't start with the digit or special word, symbols or underscore over there. Always start with the letter. After that, if you are giving underscore, that doesn't matter, or any digit, that doesn't matter. So rules are specific. Just follow it. And this, whatever the coming in blue are the keyword, and keyword is having special meaning over there. So this keyword cannot be used as an identifier. Identifier means name given to the variable or module which is coming in black over here. So these are the keyword, and these are always you need to write in small case because Verilog is a case sensitive over there. Now over here you have written module, the name of module as per your requirement, bracket, open and complete and semicolon. That is the end of this particular block where you will be putting input and outputs. Now over here there are four inputs A, B, C, D. Along with that, two select lines, these are also input, and one output, that is Y. So you need to write input A, input B, likewise input select also. Now why this is looking somewhat different, because this is of single bit and your select is of 2 bit. That's why you need to put it in vector. So input square bracket 1 is to 0, 1 colon 0, bracket complete, you need to write it in square bracket only. Don't use this type of bracket. And you need to give name as a select. So whatever nomenclature I have given over here, capital A, capital B, same I have written over here. Don't make a mistake that I0 is present over there and you are giving A. So have a that particular thing in mind. So select S is capital, that's why I have written S capital over there. So that way if you are writing, it will be proper. Now output, that is Y. Now Y I have specified this range. Range means that is the data type which is of range type, meaning of that it is having capability to hold the data, and by default nothing is present over here, means that is a wire type of data. So wire means it is a simple connection between, like that you are connecting two component using wire, so it doesn't hold the data, it don't have memory. But here range means it is having memory, so it will be holding that data. Now in behavioral modeling style, all the outputs you need to define in data type range only. If you are not writing, it will be showing you error. So keep the things in mind that all the data types in behavioral modeling style related to outputs should be a range, because it will be holding the data, and in this particular block of case statement it will be holding that value. Otherwise in between that if the value is changing, it will not be stored over there. So range data type is compulsory over there in behavioral modeling style, and output should be range only. Now once that has been done, up to this module and this input and output port assignment, the things are same like a data type. Now what is the difference in behavioral modeling style? Now this behavioral modeling style we are using case statement. Now in Dataflow you have used keyword assign. Here you need to use keyword always at. Now this is the keyword that is in small case you need to write, and in front of that there is a sensitivity list which is defined between this bracket. Now here inside that the star is written, meaning of that whenever there is an event on that input, your output is going to change. Means my Y is going to change when there is an input, when there is an event on this particular inputs. Now star is written. How that will be input? Star means all input will be considered. There is no need to write A comma B comma C comma D comma select like that. So it will be considering all input. I have written, I have told that A comma B, but you need to write A or B or C or D or select. Likewise, you need to write. So you need to separate it by or. So you can write or you can write a standing line, and that is the symbol of or. So that you can write over here in between these two brackets. So star, it will be considering all the inputs, but if you need to specify something A, B, C, D, that way also it is possible, as I told you. So once that has been done, so what is the meaning of sensitivity list? That whenever there is an event on that particular input parameter, that is A, B, C, D or select 0, select 1, that is select, so there will be change in the output. Now what is the meaning of event? That if your input is changing from 0 to 1 or 1 to 0, so that is the event. But if it is 0 only and after some time it is 0 only, so that this is not called as an event. Event means changing from some previous different value to the different value, that is from 0 to 1. So over here one time your select line will be 0 0, next it will be 0 1, so that is the change. If your input is A is 0 and next time it is 1, then it is the event, that is the your value is changing. So you need to write inputs that are affecting your outputs. That input only you need to write. You can't write y over here because you need to write inputs only, that too which are affecting your output. So hope that particular point is clear. Now you need to start. So that is begin, and once you are writing begin, so you need to same time write end. Provide some space and write end, so that that particular loop will be complete. If you have started with the model, the end module you need to write, that is the end of this module. So whole code you will be writing in between module and end module. Now what you can write inside the always. So in data flow modeling style, it is a concurrent way of programming or concurrent way of coding. But here concurrent means that is parallel, all the statements execute parallelly. But whenever we are considering behavioral modeling style, over there you are using always, and inside the always you need to write a sequential statement. What is meant by sequential statement? The statements that execute one by one, one after another. So you here you can't use any concurrent statement. You need to use if else, you need to use case, you need to use while, you need to use for. That statements only, that is the sequential statements only, you'll be writing inside always. So over here you are able to see that is case is one of the sequential statement. You have studied C, in that also you might have used case statement. So same over here you need to use. Somewhat syntactical way will be different, but the understanding is in the same way. Now, once that has been done, what you need to do, that you need to write inside the bracket which affects, means what are the different cases. So select is there, and select, if that is 0 0 you'll be getting A, if it's 0 1 you'll be getting B, if that is 1 0 you'll be getting C, and if 1 1 that is you are getting D. So whatever is the value of D, 0 or 1, we will be getting. So case is what? That is 0 0 0 1 1 0 1 1. That way you will be getting output. So that's why you need to write select inside this bracket. So case that depends upon select, and value of select will be 0 0 0 1 1 0 1 1. Now how to write that? Once the case is started, you need to end case, and that's why you need to write end case over here. In between that, you need to write different case available. Now what is written like this? To tick B00. Meaning of this is the format of showing the value. So this is the meaning is 2-bit. So what is the meaning of 2-bit binary number which is 00? So this is 2-bit number which is binary, and that's why this is 2 tick B for binary, 00. That is 2-bit they have mentioned. So that is 00 means 2-bit. Colon, that is syntax you need to follow properly. Now if that is the case, what you need to have, that y should be equal to a, means your a value will be passed to y, and semicolon, that is the end of line. Next is what? If select is 0 1, y will be getting value of b. So 2-bit binary number, that is 0 1, and colon y equal to b. Then 2-bit binary number 10 colon y, means y will be assigned as a value of c, and lastly 1 1 hai, so it will be getting value of d at the output. Now in this case 0 0 0 1 1 0 1 1, all the options have been taken, but now default value you need to put. Why? Because in Verilog data values are there, meaning of that your data might be 0, your data might be 1, your data might be Z, that is high impedance, neither 0 nor 1, it is in between 0 and 1. If I am considering 0 as a ground, that is 0 voltage, and logic 1 as a 5 voltage, so my data is in between 0 and 5 volt, that is in between that. It might be 2, it might be 2.5, which cannot be considered as a var also, and which cannot be considered as a 0 also. So that is the high impedance state, and it might be X, that is undefined. It is having value 0 or 1, but at this moment I am not knowing that, and that's why it is considered as don't care. So in Verilog, data values are 0, 1, X, that is don't care, and Z as a high impedance. So other than this, if some value is there, other than this means 0 0 0 1 1 0 1 1, if any other option is there, we have not mentioned anything. So for that we have written default, that it could have been 1X, 1Z, 1 1 0, out of that ZZ, XX. So that options we have not considered, and to avoid that situation we have given here default. So any case other than this will be present, so output will be 0. That way we have mentioned. You can mention Z also here, you can mention 1 also here, that depends upon your requirement. So end case already we have written, end also written, and end module. So this is the code we have written in in behavioral modeling style using case statement. So hope you have understood. Now one thing you need to remember, that if this case statement is written over here and 2-bit binary number 00 colon y equal to a, that only one statement is there, there is no need to write begin and end for that. But inside that, if you need to write y equal to a, y equal to z, such 4 5 or more than 2 or more than one output is present, and you need to write like that, y equal to a, then x equal to z, like that. So you need to start from begin, again after colon you need to write begin, and at the end you need to write end. Again for this line also, if two outputs are present or more than one, so you need to start with the begin and end. That thing you need to keep in mind. If one is there, that way also you can write begin and end, but there is no need, it will not be showing you error. But if more than one statement is there, definitely you need to start with begin, and that end you need to write again, then start the second option again, you need to go in that way. So this is the code for 4:1 MUX in behavioral modeling style using case statement. Hope you have understood the modeling style. Now, this code in behavioral model style can be written using if-else statement. So I'll be moving ahead fastly using behavior if-else statement. So this terminology is same, what is MUX and everything. Even model, name, ABCD inputs, output definition, range, data type, because this is even a behavioral modeling style. So data type for the output should be rich. So that you have written. Now changes will be over here. As I told you, always is the keyword that you need to use, at the rate, and this is the sensitivity list. Star indicates all the input that are affecting your output, and whenever there is an event on this parameter, that is all parameter, your output is going to change. So that is written begin. Now inside always you need to write a sequential statements, and that's why we have used previously case statement. Over here we are using if-else statement. So if in bracket select, because in that case statement, depending upon case, that is 00011011, output is going to change. So here you need to write select. So select will be 00011011. So you need to write select equal to equal to. This is the equality operator. If select value is 00, then it is true. And if that condition is true, it will be executing this. So select, are you giving 00? Yes, that is true. So it will be executing this, means y will be getting value of a. If that is false, it will be going to next statement, that is else. So again, we are having more options, 011011, and that's why after else you need to again write if. This is not there, this is the false condition, so another condition you will be checking. So if select is 0001, so it will be checking. If that is true, then it will be executing this. If that is false, again it will be checking another condition, so you need to write else. If select is equal to 10, if true, it will be executing this, else it will be executing this. So next last statement is else select equal to 11. If that condition is true, then y equal to d will be there. Now, as I told you, data values are there, 0, 1, x and z. But if you have not provided any uh, option over there, you have provided only 00011011. If that is 1x, if that is 1z or zz, so no option is provided. So in that way, you need to provide default condition that if this all are false, so else. There is no other option available, and that's why we have written y equal to 0. You can give 1 also depending upon your requirement, and semicolon. That is the end of this begin. So you have started begin over here, you have written end. And as you have started module, you need to write end module. So in this way, you are writing code for 4:1 MUX using behavioral modeling style also, as well as uh, behavioral modeling style using case statement as well as if-else statement. So um, over here, test bench you need to write. What is test bench and how to write a test bench? Related to that also video is created in Verilog code for 4:1 MUX using Dataflow modeling style. I have covered that code. Along with that, in the next video, I have covered this test bench. So what is the meaning of test bench? How to write it? So similar test bench will be writing over here. Similar in the sense, same test bench will be working over here because the same type of inputs and output is provided in Dataflow modeling style. Even input A, B, C, D, select and Y, all are defined in the same way, and that's why your test bench will be same. If you are providing select 0 and select 1 differently, then your test bench will be different for this particular point. Rest of the cases, you can use same test bench for different modeling style until and unless you are having same type of input, same single bit, multi-bit. If same kind of inputs are there, you can go ahead with same test bench for all type of code. So this is the test bench. You can go ahead with that video, what is meant by test bench and how to write it. Again, the link will be provided in the description box. So this is the simulation waveform. If input is 0, 0, you'll be getting output, that is A. So A is 1, that's why you are getting 1. Else all the inputs are 0, and that's why you are getting A1. So here that is A. Same way you are getting B, same 1 0 you are getting C because value of C is 1 over here, and for 1 1 you are getting output 1. So in this way simulation waveform you will be getting once you are writing test bench for it. So hope you understood this whole tutorial, and there will not be any issue. Just listen to this video properly and just understand it properly. Thank you everyone. Happy learning. We'll be moving ahead with the next session related to structural modeling style in the next video. Thank you everyone.